1, 2, 3, down. So, dear children, we are now coming to a meter bridge. It is a very good question. See, this is a meter bridge, and then on the left there is a magnet wire, you can say, a magnet wire of 150 centimeter, and here this one is balanced by 10 ohms at the ratio of 3:2. So if you do this, 3x plus 2x is 100, so you will get OB will be 60, and then the remaining BA will be 40. So now, with stone bridge, P by Q is equal to R by S. P by Q, R by S. So you will get P by 10 will be 60 by 40. So you will get P is equal to 15 ohms. Now, in unitary method, be careful. What do they want in the problem? They want 1 ohms belong to how many centimeter of the manganese wire. So whatever is needed in the question, it should be on the right hand side. Remember, that is the basic of unitary method you have learned in your class 4, class 5, class 6. So 15 ohms belongs to 150 centimeter. So 1 ohm is very simple, is 10 centimeter, or 10 centimeter is 0.1 meter. So that is the answer. Now, this has got a tremendous effect on what we are going to do with this wire. See, we have seen this wire is 150 centimeter. Now, in our resistance box, you can see here, this is a resistance box, and then here there will be 5 ohms, 10 ohms, 20 ohms, 30 ohms, just like this. See, here this is brass, 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 brass. So when you put this plug here, when you plug this plug here, this wire is short-circuited, so this is 0. The moment you pull up this plug, this wire here will have its resistance equal to the resistance of the manganese wire, which is wound here. Now, here is the problem. How can you wind 150 centimeters, about 8/10 of them inside this box? So you have to wound it on a wire. You have to wound it on a piece of wood. You have to wound it. And while you have to wind it. And while you wind it, you should be careful. Because if you wind it in clockwise direction always, then there is a problem, because we are dealing with the change of current. And you might have got from Faraday's law of electromagnetic induction, or from the theory of a solenoid, the self-inductance. Whenever there is a change of current, there is a huge change of induced EMF, and it will damage the ammeter or the voltmeter. This is very dangerous. So how they do it? See, a 200 centimeter of wire is wound on this, say this much size. So you wind it in the clockwise direction, and see this dotted line now, it is a wire. Then when you reach here, you wind it in anti-clockwise direction. So now, what happens when there is a change of current? When you plug or unplug this, there will be change of current. So the change of current, the magnetic field of with clockwise will be balanced by the magnetic field by the anti-clockwise. So this is known as non-inductive winding. I'll be doing this on the next class also, on the next lecture. So remember, this is non-inductive winding. So remember, a resistance box has got manganese wire, or you may say any wire, nichrome wire, but they should be wound in clockwise and then anti-clockwise to avoid the induced EMF. See, for example here, very simple, a 12-volt car battery, ammeter, and this is the coil, and this is the bulb of 12 watts. So now, I on this for say 3-4 milliseconds, there will be induced EMF. Forget about that. It will die down and L will be simply a conductor. It will not do anything. Forget about that. So what is the current? 12 watts is the bulb. So because it is 12 volt, so B into I is 12 watts. So the current in the ammeter will be 1 ampere. That is good. Now, what happened when I suddenly switch? This switch, I suddenly switch it to OB. See, I suddenly switch it to OB. Now, this is cut off, so the current remains from 1 ampere, it suddenly switched to 0. That is okay, 1 ampere to 0. But in what time? Say, if it is 0.01 second, see, what is the induced EMF? Minus, because it is opposite to this, minus L di dt. Okay. L into 1 ampere, say the change is in 0.01 second. I switch it in 0.01 second. So what you will see here, it will be L into 100 volt. So even if L is point Henry, the voltage may go to 16 volt or to 18 volt, and you may find that this bulb may fuse altogether. Or sometimes you will see, if you are lucky, the bulb will be just bright for some time. It will not fuse, but it will be brighter than it was. So this is very risky. So this is the danger in dealing with a coil. So whenever you make anything for resistance box and all this, be careful. The coil should be like this, clockwise and anti-clockwise. So the change in magnetic field will be balanced, clockwise will be balanced by anti-clockwise. So we'll come next day, I'll stress some more on this. So that is the end of this, so good night.